Question 7, Part B. A cooler, which is initially full, is drained so that at time t seconds, the volume of water, V, in litres, is given by V equals 25 times 1 minus t over 60 in brackets to the power of 2 for t greater than or equal to 0 and less than or equal to 60. Part 1. How much water was initially in the cooler? The initial volume of water is found by evaluating V when t is equal to 0. So V of 0 is equal to 25 times 1 minus 0 over 60 in brackets to the power of 2, which equals 25. Therefore, the initial volume of water is 25 litres. Part 2. After how many seconds was the cooler 1/4 full? We want to solve for t the equation 1/4 times 25 equals 25 times 1 minus t over 60 in brackets to the power of 2. Now it's 1/4 times 25 because we want to find the time when the volume of water in the cooler is 1/4 of its maximum capacity. So that's why it's 1/4 times 25 on the left-hand side. So we can divide both sides of the equation by 25. So we end up with 1/4 is equal to 1 minus t over 60 in brackets to the power of 2. Taking the positive square root of both sides, we get 1 over 2 is equal to 1 minus t over 60. Rearranging this equation to make t over 60 the subject, we get t over 60 is equal to 1 minus 1 over 2. Now 1 minus 1 over 2 is just 1 over 2. So the equation becomes t over 60 is equal to 1 over 2. Multiplying both sides of the equation by 60 to make t the subject, we get t is equal to 30. Therefore, the cooler is 1/4 full at time t equals 30 seconds. Part 3. At what rate was the water draining out when the cooler was 1/4 full? The first derivative of V with respect to time t, or V dash, gives us the instantaneous rate of change of water draining out of the cooler at time t seconds. So in this case, V dash is equal to d dt of 25 times 1 minus t over 60 in brackets to the power of 2. Now 25 is a multiplying constant that can be taken outside of the derivative. So V dash is equal to 25 times d dt of 1 minus t over 60 in brackets to the power of 2. Now we need to apply the chain rule to differentiate this function. So that equals 25 times 2 times 1 minus t over 60 multiplied by the derivative of what's in brackets here, which is negative 1 over 60. And that simplifies to V dash equals negative 5 over 6 times 1 minus t over 60 in brackets. Now at time t equals 30 seconds, V dash is equal to negative 5 over 6 times 1 minus 30 over 60. And that simplifies to negative 5 over 12. So we interpret this negative here as water draining out of the cooler. So the volume is decreasing over time. Therefore, the cooler is draining at a rate of 5 over 12 litres per second.